2, properties of functions. Learning target 3, the good news is this is the last type we're going to look at. So we're going to look at scenarios, or you can call them contexts, and we're still going to identify the slope and the y-intercept, but it's just going to be looking at the scenario or context. So a couple things. How do I find that slope if I'm not given any numbers to look at or a graph to look at? So you're going to look for the words per, each, every. Those will give you a clue that you are looking at the slope, because remember, slope is rise over run. So it's that feel of like rise per run or gallons per mile or whatever you're looking at. So it's that idea of a ratio, a per idea. Your second one is, how do I find that y-intercept? Well, you're going to look for the phrases, because remember, the y-intercept is at when x is 0. So you're going to look for her at the start. So at the beginning, or already has done, or any of those ideas that tell you what had happened before or what has happened at the start. And then that slope's going to tell you what's going to happen from the moment on. So we're going to look at these contexts. So we have Mila, and I changed this around from in your paper. So just look at it. You can add it to, or just follow along on the video here. Mila is sitting in math class and has not taken any notes. She has taken 4 pages of notes. She is taking 4 pages of notes per hour. So slope looks like rise over the run, or the change of the y over the change of the x, however you like to look at it. So I told you to look for the word per, each, or every. So as I read that, I quickly see she is taking 4 pages of notes per hour. Per meaning that division bar. So what goes on top? 4 pages of notes. 4 pages of notes. What goes on the bottom? Per hour. Per 1 hour. And there I have the slope. So when you're looking at a context, you just have to identify what part of that context is your slope and look for the word per. Y-intercept. So if you think about this, I have told you multiple times that x is 0. Okay, so we're looking for the y value. Sometimes this is a context, I like to put the labels on it, so I keep that idea of the context flowing. So remember, x has to do with hours. X has to do with hours. So at the 0 hour, so in other words, at this moment when we're going to start calculating the slope in, at 0 hours, how many pages, because that's your y is pages, how many pages has Mila taken notes on? So if we look back, Mila is sitting in class and has not taken any notes. So that tells me she's taken 0 pages of notes. So last thing is put into your equation format. So y equals m, my slope, 4 pages per 1 hour. I can simplify that just to 4. X plus, and my y-intercept, since at 0 hour, she had taken no notes. That means your y-intercept's at 0. It's going to start at 0, and she's going to take 4 notes per pages, 4 pages of notes per hour. Okay, our next one. Aubrey has already knitted 4 centimeters of her scarf. She plans to knit an additional 3 centimeters each night until the scarf is complete. Okay, so I'm going to look for slope. So how much my rise over my run, or my y over my x. So I'm looking for the word each or per. So I see it right there as each. So that means that's my division bar. So she plans to knit an additional 3 centimeters. That's the top. 3 centimeters per, or each night. So 3 centimeters each night. I'll rewrite that so it looks nice here. So that is my slope. I'm going to look for the words already, started, at the beginning, something like that. So it says Aubrey has already, there's my word, knitted 4 centimeters. So at the beginning, so when it's 0 nights, because this is when we're going to start including the slope of 4 or 3 centimeters per night, at 0 night, at where we're starting from, not like at the beginning of this project, but right now in this point in time where we started from, at the 0 night, she has already knitted 4 centimeters. And that totally makes sense. So we're going to make that equation y equals, my slope is 3 centimeters a night, so I'm just going to write that as 3. The value of x, so I can figure out how many centimeters she has after so many nights, and then she has already knitted the 4, so my y-intercept is 4. Next problem. A puppy named Cricket started out at 2 pounds and has gained 5 pounds every month. So y over x, rise over run, I find that word every. So so before that it says gained 5 pounds, so there's my top, 5 pounds. There's my line for every, and then month, 1 month. It doesn't say more than 1 month, it says a month. Okay, at the y-intercept, so at 0, so at the beginning, remember x is talking about months, so I'm going to put 0 months to keep my label on here. So at 0 months, let's look, the puppy started out at 2. So at 0 months, in other words, when it was born, it weighed 2 pounds. So that has to be my y-intercept. That's where I'm going to start my graph from, 0, 2. The equation then is y equals, my slope is 5 over 1, so I can reduce that just to 5. My variable x plus the puppy started at 2 pounds, so at 2 pounds. And the last one. Nick is given $50 to spend on his vacation. He plans to spend $5 a day, or each day, or per day. So I can hear it. I see the word per. So what's before it? It goes on top. So it's $5. And then on the bottom is a day. Now, this one's a little bit interesting because it says spend. So since you're spending money, you're going to lose $5. So we have to make that a negative $5. Look for the y-intercept. So at 0 day, so at the 0 day, it says Nick is given $50 to spend. So at the beginning, before he goes on vacation, he has $50. So that would be your y-intercept. So our equation would be y equals negative, because he's spending money, 5 over 1 could reduce to 5x plus the y-intercept is 50 because he had $50 to spend. Go ahead and try your practice packet looking at contexts or scenarios on page 23.